Hey Space Friend, today we're going to fix the ship's temperature and humidity monitoring with a DHT11 sensor. The DHT11 and DHT22 sensors are used to measure temperature and relative humidity. Relative humidity is the amount of water vapor in the air versus the saturation point of the water vapor in the air. Water vapor begins to condense and accumulate on surfaces forming dew at the saturation point. These two sensors are pretty similar, but here are some notable differences between the two. Which one you use just depends on your needs. The DHT11 takes a reading every second and is cheaper, but it has a smaller range and is less accurate than the DHT22. Regardless of which you use, the code will be pretty much the same with the exception of choosing the right sensor type. The sensor detects water vapor by measuring the electrical resistance between two electrodes. The component that senses humidity is a moisture-holding substrate that has electrodes applied to the surface. When the substrate absorbs water vapor, it releases ions that increase the conductivity between the electrodes. The change in the resistance between these electrodes is proportionate to the relative humidity. The resistance between electrodes is decreased with higher relative humidity and increased by lower relative humidity. The DHT11 senses temperature with a surface-mounted thermistor. This is a combination of the words thermal and resistor, and for some reason is really hard for me to say. It's a type of resistor whose resistance is strongly dependent on temperature. There are two common types of DHT11 sensors, one with 4 pins and one with 3. Both sensors have a pin for 5 volts, ground, and a line to transmit the data to the Arduino. It requires a 10K ohm pull-up resistor between the signal line and 5 volts to keep the signal level high by default. The 3-pin sensor typically comes mounted on a PCB or printed circuit board, which includes a mounted version of this resistor, so you don't need to use an additional one. On a 4-pin sensor, one of the pins is considered an NC pin, or not connected. There's a lot of reasons that a sensor might come with a not connected pin. Sometimes it's to remain compatible with another part, it may have been used for production testing by the manufacturer but isn't used outside of the factory, or it's used for mechanical reasons once it's mounted onto a PCB. The DHT11 sensor requires some libraries to be installed before we can use it. Go to Sketch, Include Library, Manage Libraries, and search for DHT. Find the DHT sensor library by Adafruit. It may ask if you want to also install the dependent library, so go ahead and do that too. If it doesn't ask you that, then also search for Adafruit Unified Sensor and install that as well. First, let's just output the data to the serial monitor to see how it works. We need the sensor and 3 male-to-female jumper wires. Connect the VCC line to 5 volts, ground to ground, and the S pin to pin 2. First, we need to include the DHT library and define a few things. The pin we're attaching the sensor to, which is pin 2, and the type of sensor. If you're using a DHT22 sensor, all you need to do is comment out this DHT11 line and then uncomment the DHT22 line. On the next line, the DHT in all caps is the name of the class provided by the DHT library. It's how we interact with the sensor. The lowercase DHT is an object of that class. We'll use it to access the functions associated with the sensor. Then we entered the parameters pin and sensor type, which we defined above. The setup is initializing the serial monitor and then initializing the sensor using begin. The loop creates 3 floating point variables for the humidity, temperature in Celsius, and the temperature in Fahrenheit. The default for the sensor is Celsius, so when we put true as the argument for read temperature, that sets it to Fahrenheit. Then we print the reading for each of those variables to the serial monitor and delay it by 1 second. Now we're going to print the temperature and the humidity to an LCD using a bit of a different method. We still start by including our libraries, defining the pin number, the DHT type, and then creating the class and object. The difference is we need to add in this include liquid crystal I2C and the I2C information. This looks different for different types of LCDs though. I'll include a link in the description to the specific type of LCD that I'm using so that it matches this code. I'll also include a link to a video about how these LCDs work if you want to get a little more in-depth information about it. In the setup, we are initializing the sensor and the LCD and then also turning on the LCD's backlight. In the loop, we are first going to set our cursor to 0, 0. This is the first row and the first column, so the upper left-hand corner of the screen. Then the way that we're reading the temperature this time is we're going to do float dht.readTemperature, and then I'm setting it to true for Fahrenheit, but you can leave that alone if you want to keep it at Celsius. LCD.print car223 is how you print the degree symbol. You typically have to check the datasheet for each device to get the right value for different symbols. Admittedly, I couldn't actually find the datasheet for my specific LCD, so I had to Google this. But here's an example sheet that shows the symbol, decimal value, and binary value. You may also find a data sheet that looks like this, where you have to actually do your own binary conversion. Let's say you want an exclamation mark. You start with the column and then the row, so the binary value is 00100001, which converts to 33 in decimal. The next set cursor function is setting the cursor to 0, 1, which is the first place on the second row. We're going to read and print the humidity the same way, which is declaring it as a float, and then dht.readHumidity. Then we print the percentage sign and delay it all by 2 seconds. Another ship part fixed. Oh, not again. The lights in here keep flickering as if the alarm is going off or something. Wait, the message on my LCD just changed. Well, that seems bad. Okay, normally I'd let this be a problem for my future self, but this feels like a look into it urgently kind of situation, so I gotta go.